Now that we've talked about the basics of solving equations, we want to start working towards solving more complex equations. And in this video, we're going to talk about equations in which we have variables on both sides. I have an example of an equation here, and I want to find out what x is. I want to solve for x. What value of x makes both sides of this equation balanced? And you'll notice that the one new thing we have is we have x's on both sides of the equation. All right. So our strategy is we basically need to get x on one side of the equation and the constants or numbers on the other side. So there's a couple of ways you could approach this. I'll notice I have 3x and I have 5x. And let's suppose we want to put our variables on the left side. All right. So in order for that to happen, we're going to have to get rid of the 5x on the right side. So to get rid of positive 5x, to undo it, the inverse operation would be to minus 5x on both sides. Whatever we do to one side, we do to the other. And you'll notice on the right, 5x minus 5x, that's 0. And so we're left with negative 3 on the right. And on the left, we have 3 minus 5x, which is negative 2x, and my minus 7 is still there. And you'll notice I've eliminated my variable on the right side. And now we're down to an equation that we've experienced before. We have the x on the left side. We want to get rid of the negative 7 on the left side because we want all the variables on one side and all the constants on the other. So to undo the effect of minus 7, we're going to have to add 7 to both sides, inverse operation. And then we have negative 2x. These two together are inverses, so they add to 0. And negative 3 plus 7 is 4. We're getting closer and closer to getting x isolated. We have negative 2 times x, so to undo negative 2 times, we have to divide, inverse operation, both sides by negative 2. And so we come down to x is negative 2. All right, and let's check our equation by substituting back into the original. Let's just show our check over here. If we place negative 2 in for x on the left side, the question is, does that question mark equal 5 times negative 2 take away 3? Well, this would be negative 6 minus 7, negative 10 minus 3 on the right, and this is negative 13, and this is negative 13. The equation is balanced, so we know that x equals negative 2 is our solution. Let's do one more example. Here's a more complex equation. Now the first thing I'm going to do here is I'm going to simplify both sides of the equation independently. So here I'm going to distribute, here I'm going to distribute. Let's just do that. So that's going to be 4x take away 2x minus 10 equals negative 6 minus 4x minus 4. And then I'm going to simply simplify both sides independently. So 4x minus 2x, like terms, that's 2x. And over here we have negative 4x. Negative 6 minus 4 is negative 10. So at the moment we have x terms on both sides. I want to get the x on one side, let's say on the left side again, which means I want to get rid of this x term on the right side. So negative 4x, to counteract that, I'll add 4x. And that will be 2x plus 4x, 6x minus 10 equals, this is 0 when I add, equals negative 10. X's are isolated on the left, but we have constants on both sides. If the x is isolated on the left, then we need to get the constants on the right. So to undo the minus 10, I'm going to add 10 to both sides. So 6x, this adds to 0, equals 0. 6 times x equals 0. To undo the effect of 6 multiplied, we will divide both sides by 6, and we will get x equals 0. And let's check that out. Just write up my check here. Check. Putting 0 in wherever I see x. So it's 4 times 0 minus 2 times 0 plus 5. That's going to be my left-hand side. Let's just work that out. That's going to be 0 minus 2 times 5, negative 10. So the left-hand side comes out to negative 10. Now let's do the right side. substituting 0 in for x, equals the right-hand side. 0 plus 1 is 1, times negative 4 is negative 4, negative 6 minus 4 is negative 10. And the right-hand side equals the left-hand side, therefore x equals 0 is my solution.